Hi guys, let's look at the next exercise 22b. The concept still remains the same. We will need to figure out the height and distance between objects using the trigonometrical functions. Perfect. So let's look at the question. Find the height of a tree when it is found that walking away from it 20 meter in a horizontal line through its base, the elevation of the top changes from 60 to 30. Perfect. So let's just draw a rough diagram. This is basically the tree and this is the ground, and originally the angle of elevation is 60 degree, and then the angle of elevation changes to 30 degree by walking 20 meters away. Perfect. So let's just mark all of this. This is A, B, original point, let it be C, final point is D. This is original elevation angle is 60 degree, final angle of elevation is 30 degree, and the difference between C and D is given to be 20 meter. Perfect. What do we have to calculate? We need to find the height, which means we need to calculate the value of AB. Okay, so let AC is equal to X meter and AB is equal to Y meter. So this is X and the height that we need to calculate is Y. Perfect. So now we have two triangles. Let's see if we can apply trigonometry and calculate some ratios. So let's look at it. So in right triangle ABC, that the smaller triangle first, I have tan 60 degree is equal to AB upon AC. Tan 60 degree is equal to root 3, which means root 3 is equal to AB, which is Y, upon AC, which is X, which means Y is equal to X root 3. That's my first equation. Let's look at the second triangle, which is in triangle ABD. Next, again, it will be the tan function. So tan 30 degree would be equal to AB upon AD. Tan 30 degree is 1 upon root 3. AB is Y and AD is equal to X plus 20. So let's solve this one. This would become Y root 3 is equal to X plus 20. Perfect. Since we need to calculate the value of Y, let's equate X. So from equation, so let us give this equation number 2. Equation 1 gives me X is equal to Y upon root 3, and equation 2 gives me X is equal to Y root 3 minus 20. Perfect. So X is equal to Y root 3 minus 20. So let's equate them, which means Y root 3 minus 20 is equal to Y upon root 3. Let's add this. So this would be, let's cross multiply. So this would be 3Y minus 20 root 3 is equal to Y, which means 3Y minus Y is equal to 20 root 3. 2Y is equal to 20 root 3. Therefore, Y is equal to 10 root 3. As per your log book, the square root table, root 3 is equal to 1.732. Therefore, Y is equal to 17.32 meter. We need to find the height. Therefore, height is 17.32 meter. That's the final answer. Perfect. Very simple. Let's move on and solve the next question. The next question that we solve is question number 4. Question number 4 says, from the top of a lighthouse 100 meter high, the angles of depression of two ships are observed to be something and something. Find the distance between the two ships. We need to calculate it to the nearest meter. So that's important to note that they wanted the answer in the nearest meter. One, if the ships are on the same side of the lighthouse. So let's first do this part where the ships are on the same side of the lighthouse. So let's just draw a rough diagram. So this is my lighthouse, and we have the two ships coming. First ship, the angle of depression is given as 48 degree. The second ship, the angle of depression is given as 36 degree. Perfect. So Common mistake which students do, which I'm highlighting, they clearly end up writing this as 48 and this is 36. Please note, angle of depression is the angle which the line of sight makes with the imaginary horizontal axis. So first thing important is for you to draw the horizontal axis. So the bigger angle here is 48 degree, the smaller angle is 36 degree. So this is 36 degree, this is 48 degree, because these are parallel to each other. Let's mark this as 90 and let's give them some names. So this is A, B, C and D. Perfect. From the type of a lighthouse which is 100-meter high, which means AB, the height of AB is 100 meter. Perfect. Find the distance between the two ships. So we need to find the distance between them, which is, this is ship 1, this is ship 2. So I need to calculate the value of CD. Let this be X and let this be Y. Right. So we've assumed let BC is equal to X meter and CD is equal to Y meter. Now we have two right angle triangle. Let's apply the trigonometry functions and see what will I get. So in triangle ABC, number 1 would be tan 48 degree is equal to AB upon BC. If I need to calculate value of BC, I realize BC is in the denominator, which means my tan 48 will come in the denominator if I have to calculate BC, which means I will end up dividing by a decimal figure. So you should keep this in mind, that whenever you need to find a figure or find a number, a variable, it should always be in the denominator. Let's continue with this and you will figure out the problem that we face. So tan 48 degree, let me just go through your log book and check the value of tan 48 degree. Tan 48 degree is 1.1106. So 1.1106 is equal to 100 upon BC, which is in this case X. So X is equal to 100 upon 1.1106. Like I've shared, slightly more difficult to do this calculation. That's why I'll ignore this and I'll use the complementary angle method, which is in triangle ABC, 48 degree plus 90 degree plus angle BAC is equal to 180 degree. Therefore, angle BAC is equal to 180 minus 138, which is equal to 42 degree. So this is equal to 42 degree. So now I'll apply the tan 42 degree method. So that's tan 42 degree in this case would be equal to BC upon AB. Tan 42 degree, the value is 0.9004 multiplied with AB, which is 100, is equal to BC, which is X. So I've got value of X. This is, therefore X is equal to 90.04 meter. Done. Let's look at the second triangle. So in triangle ABD, again I notice this is 36 degree and I would end up having X plus Y in the denominator. So this is 36 degree plus 90 degree plus angle BAD is equal to 180 degree, which means angle BAD will be equal to 180 minus 126, which makes it 54 degree. So again I'll refer to the second angle, complementary angle to the one which is given, and calculate the tan value of this. So tan 54 degree would be equal to BD upon AB. Tan 54 degree is equal to 1.3764. This is from your book, multiplied with AB, which is 100, is equal to BD, which is X plus Y. So this is 137.64 is equal to X plus Y. I already know, so put X is equal to 90.04, which gives me 137.64 minus 90.04 is equal to Y. 137.64 minus 90.04 is equal to 47.60 meter. Perfect. So therefore distance between ships is 47.60 meter. Let's look at the second part of the question. The second part of the question says if these ships are on the opposite side. So let's just do a rough diagram and see how it will look. This is how basically it look. There is one ship which is making an angle of 48 degree. Another, so not this one, my mistake. This is not the 48 degree angle, the angle of depression. This is 48 degree, and the second ship is making an angle of 36 degree. Perfect. This is parallel, which means this angle is 48 degree and this angle is 36 degree. If I name the same thing, this is A, this is B, the first ship is C, the second ship is D. Here we've already calculated the value of BC, which is X, which is 90.04, and we've already calculated the value of X plus Y, which is BD also, which is, this is equal to BC, and we calculated BD as 137.64. So the distance between C and D, therefore CD would be equal to the addition of this, which is 0.68, and that's 722. So 227.68. I suddenly realized I've made a mistake. They wanted the answer to the nearest meter. So that's the mistake that I've done. So I will need to change this. So is 48 meter. I'll have to round it off to the nearest meter. In this case, it is 227.68, which means I will round it off to 228 meters. So if they are on the opposite sides, the distance between them is 228. If they are on the same side, then the distance between them is 48 meter. Very interesting question. Let's look at the next one. The next question that we're doing is question number 7. Question number 7 says the angle of elevation of the top of a tower is observed to be 60 degree at a point 30 meter vertically above the first point of observation. The elevation is found to be 45 degree. Okay, so we are observing the tower from two different points. The first one is on ground, and then the second one is exactly above it, approximately, not approximately, 30 meter higher than that. Perfect. So this is my tower. This is the 90 degree angle. The tower, I'm naming it as AB, and the elevation of the top of a tower is 60 degree. Perfect. So let this be the the first angle of elevation, which is, in this case, we are taking it to be 60 degree. Perfect. Let me just rejoin this properly. Done. So this is 60 degree. Next, at a point 30 meter vertically above this, which means we are going exactly above this 30 meter. Okay, so let me mark this as 90 degree because this is exactly vertically above it. This is 30 meter. Next, the angle of elevation from this point is observed to be 45 degree, which means I will have to make the reference horizontal. This is my reference horizontal. This will make a 90 degree angle, and this angle is 45 degree. Let's read if I have done any, if I missed out something. I have named the place of observations as C and D. Angle of elevation of the top of the tower is observed to be 60 degree. At a point 30 meter above this, the angle of elevation is 45 degree. Perfect. Find the height of the tower and its horizontal distance from the point of observation, which means I need to find BC and I need to find AB. Let me name this point E. Quadrilateral BCDE is a rectangle. What it means is, so this is point number 1. Point number 2 would be BC is equal to DE, and point number 3, CD is equal to BE is equal to 30 meter. Again, I have two right angle triangle. Let's apply tan ratio and get the value. Perfect. So now let the value of AE be equal to Y, because BE in any case we know is 30. Done. So let's look at this. So this is number 4 we've taken as let AE is equal to Y. Next, in triangle AED, we're looking at triangle AD. Tan 45 degree is equal to DE upon AE. We've not taken a variable for DE, so let this be X. Similarly, DE is X. So BC is equal to DE is equal to X. Right? We've taken this variable now. So tan 45 is 1, which means AE is equal to DE, which means X is equal to Y, which means AE and DE are basically equal. I could have replaced this with X, doesn't matter. So that's our first thing that we've got. Let's see if we can get something from the second triangle. So in triangle ABC, again we will have tan 60 degree is equal to AB upon BC. Now AB is equal to X plus 30 because AE is Y, which is equal to X. So tan 60 degree is root 3, which is equal to 30 plus Y upon X. But let's just replace that. Root 3 is equal to 30 plus X upon X, since X is equal to Y. Next, X root 3 is equal to 30 plus X. X root 3 minus X is equal to 30, which means X times root 3 minus 1 is equal to 30. X is equal to 30 upon root 3 minus 1. Let's rationalize this. I rationalize this with root 3 plus 1. So root 3 plus 1 here. So I have X is equal to 30 into root 3 plus 1, that's 1.732 plus 1, which is 2.732, and this is a plus b into a minus b, that's 3 minus 1, that's 2, which means 2 1 to 15. So X is equal to 15 into 2.732. Let's do this calculation. 2.732 multiplied with 15, that's 10, 15 and 1 16, 35 and 1 36, that's 10 and 3 13. This is 2 3 7 2, that's 0 8 9 10 4. So 40980. How many decimals? 3. That's 40.98. Therefore X is equal to 40.98 meter. What do we have to calculate? We need to calculate the height of the tower. So height of tower is equal to 40.98 plus 30, which is equal to 70.98 meter. So that's the first part, and the second part is horizontal distance, which is X. So distance is equal to 40.98 meter. Done. Let's look at the next question. The next question that we do is question number 8. Question number 8 says, from the top of a cliff 60 meter high, the angle of depression of the top and bottom of a tower. Also, we are looking at two angles from one place. Perfect. So let's just draw the cliff first. So this is my cliff. The angle of depression of the top and bottom of a tower. Let me just draw the ground now. So this is the ground, and on the ground is a tower. Perfect. Let's just mark them. This is cliff. This is tower. Again, let me mark the 90-degree angle and the angle of depression of the top of a tower. So let's mark the angle of depression. Yeah, so the angle of depression of the top of a tower, and then we have angle of depression of the bottom of a tower as well. So this is the angle of depression of the bottom of the tower. To mark the angle of depression, I will have to draw the imaginary horizontal, which is what I'm doing now. Perfect. So done. This and this are parallel. The small, and I will have to draw this horizontal as well. Done. So let's look at the angles. This angle, which is the angle of depression of the top of a tower, is given equal to 30 degree. So this angle is 30 degree, and the angle of depression of the bottom of a tower, which is 60 degree, which means this angle is 60 degree. Let me give them some names. This is A, B, C, D. Let this point be E. Perfect. So we need to find the height of the tower. So this is what we need to find. Let this height of the tower be X. Let this also be X. And the cliff is 60-meter high, which means AB, the total is 60, which means AE is equal to 60 minus X. Let's just write that down. Number 1, AB is equal to 60 meter. Number 2, let CD is equal to X. Since quadrilateral BDCE is a rectangle, therefore point number 3, CD is equal to BE is equal to X. Number 4, AE is equal to 60 minus X. Done. So let's see if we can figure out something from here. And number 5, let BD is equal to CE is equal to Y. All this is in meters. All this is in meters. Perfect. So this is Y and this is also Y. Done. Now we have two triangles. Let's apply trigonometrical function. So in triangle, let's look at the smaller triangle. In triangle AEC, I have tan 30 degree is equal to AE upon CE. Tan 30 degree is 1 upon root 3, AE is 60 minus X, and CE is Y, which means Y is equal to 60 minus X times root 3. Done. Next, in triangle ABD, I have tan 60 degree is equal to AB upon BD. Tan 60 degree is root 3 multiplied with BD, which is Y, is equal to AB, which is 60. So root 3Y is equal to 60. What we need to find? We need to find the height of the tower, which means I need to find X. So let me equate Y so that I am left with only variable X. So let me call this equation 1. Done, which means this equation will give me Y is equal to 60 upon root 3. This is equation 2. So equate, since both of them are basically values of Y, so let's equate 1 and 2, which means 60 upon root 3 is equal to 60 minus X times root 3. Let's see if we can solve this further. Let's cross multiply. What it gives me is 60 is equal to 60 minus X times root 3 into root 3, that's 3. So which is 60 is equal to 180 minus 3x, which means 3x is equal to 180 minus 60. 3x is equal to 120. Therefore, x is equal to 40 meter. What do we have to calculate? Find the height of the tower. Therefore, height of tower is 40 meter. I hope you've been enjoying this class, this chapter. Nothing much to it, as long as you're able to read the diagram correct and you're able to apply the trigonometrical ratios. Some homework questions for you. Homework would be question number 1, question number 3, question number 5, and question number 6. Thank you so much. Take care. Be safe. I'll see you with the next video.